So actually, whenever we are finishing one presentation and then another presentation, concentration will go in the last one. So many points may be missed. So it is better to continue the discussion immediately after the presentation. So first 10 minutes is the presentation. Immediately after that, 5 minutes we can discuss on the presentation. Is it all right? Okay. Okay. Thank you very much. So actually, in this session, it was assigned 5 papers, but 4 papers will be presented. I saw this abstract and title. So I think it's covering the technology of toilets, sanitation, and also the management part. So basically 2 parts is covered in this research and presentation. So first presentation, and that is actually a modification of pit latrine, conventional pit latrines. So that will be in this title, the transformative pit latrines into on-site treatment unit. So far it will be presented by Bara Wahbeh. So I would like to invite Bara Wahbeh to present this paper, and then we can discuss on this paper presentation. Thank you very much.
Thank you, Doctor. Good afternoon, everyone. My name is Bara. I'm the Executive Director of AKYAS Environmental Consultancy. It's tough to have a presentation after the lunch, huh? It's time for siesta. Okay, thank you. Let me know when the slides are ready. So we are a D&D company. We discover and develop solution, and we're focused today to talk about the effluent divergent unit. It's a plastic fitting that we plug it to any pit latrine, and we transform it from a containment unit to on-site treatment center. So why pit latrines are important? Because 1 in every 4 people in the world use it. And whether if you have a good pit or a bad pit, the pit will get filled. It's a matter of time. Then you need the whole FSM challenge. Now, when we look really, if you zoom in and look what goes in the pit, it's more than 97% of it is liquid. It's a mix of flush water, cleansing water, urine. And only 3% is solid waste. If you zoom out and you take 1 meter cube, 1,000 liters, this means only 30 kg is fecal waste, and 970 liters is water. And when both mixture mix, you end up with a fecal sludge that you need to treat the whole mix. So I think the solution is straightforward, just separate it. 50 years ago, the first urine diversion pan was introduced to the market in 1970. It's over there. You see the marker? Yeah. Yet it did not scale. Simply, it required a lot of user behavior change. People didn't like it. You need to jiggle forward and backward and all of this mess, 5 years ago, we introduced the AKYAS liquid diverting pan. It has 1 hole, so we overcome the behavior change aspect. But people in the region, in Jordan and Turkey, where we put the unit to test, did not like it. The aspiration of people was a flush toilet. So we took the learning from both units, and we said we need to have a back-end system, no interaction with the people, and it should focus on offset pit latrine. So this is the concept behind the EDU. So the EDU is a plastic fitting. You plug it to any 4-inch pipe, and it's installed inside the pit latrine. And simply, it do 2 things. First, it will divert the fecal matter inside the pit. And second, it will push the liquid outside the pit. By doing so, you decrease the filling rate by 20x. And the effluent leaving is almost clean, that can be treated and discharged on site. So it's a game changer when we think about FSM. Now, the advantage of the EDU, as it's placed inside the pit latrine, no behavior change, and as we plug it to the 4-inch pipe, we can utilize the existing infrastructure, like the toilet shelter, the pipe, the pan. You don't destroy anything. And we did a couple of retrofitting projects here in Bangladesh. So the EDU can unlock maybe a matrix of a different combination. Total, we have almost 20 different combinations. Here on the x-axis, you can see effluent treatment technologies. So in Bangladesh, we're focused on settling tank and biosand filters, or anaerobic reactor with a leach field. We chose this system because it's really compact. In Jordan, a water-scarce country, we were focused on collecting the water, harvesting the water. And in Kenya, we did a constructed wetland. With respect to the fecal management, either we dehydrate the fecal matter, in 2 weeks it loses 40% of its volume, or we use worms, or enzyme. In terms of form, mainly the main challenge you face is if they get in touch with chemicals or chemical cleaning component, they die. If there is a lot of water in the pit, they suffocate. So by diverting everything outside, you manage to keep them alive. And in terms of enzyme, the more water comes to the pit, it will dilute and lose its value. So I think the EDU make a fantastic work in making this technology more durable and working better. So this is a cross-section for one of the installations in Bangladesh. You can see the ADU is installed inside pit number 1. In pit number 2, what we did is we split the pit into 2 chambers. Chamber number 1 is a settling tank, followed with an anaerobic reactor or a biosand filter, and we catch to a leach field. From here, we were collecting the sample and all along. Now, designing the system, we kept in mind that was an iterative process that took more than 2 years to tap to the existing supply chain. So we used everything starting from the SATO-I trap to S-trap to all the other components in the market. Because we believe to enroll this product and make it grow in the market, we need our partner and stakeholder to make profit out of it. And we make sure they make profit more than us. And when we do a retrofitting, the cost of the whole system is $60. When we do a full 2-pit installation, it's around $140. The ADU was priced as $10. You can see here one installation is in I shape and one installation is in L shape. So the system is really flexible in terms of the strain you have on the field. This picture is to talk about the system, the performance of the system. So we collected more than 10 samples along the last 12 months. The numbers represent where we collected the samples. So this was our reference sample. The y-axis represents a concentration ratio. The x-axis is time, so it's around every 24 hours. From point 1 to point 3, it takes almost like 5 seconds. From point 3 to point 5, we're talking about 24 hours. We had 7 main indicators. Here I'm only showing the BOD in blue line, and the red line is the pathogen. You can see we have a massive reduction in the BOD after point number 2, and that's why the ADU removed all the fecal matter. And the pathogen, when they went to our biosand filter, we managed to drop it by 98%. We start with millions, we end up with a couple of thousands CFU per 100 mil. And what we saw with time, the biosand filter get more matured and remove more. So what we did in Bangladesh was trying to understand what's the willingness to pay of the people, and what we played the role of manufacturer and supplier to a couple of SEs in each district. The SEs will utilize the existing sales promoter to promote the unit to the households through an awareness campaign. And what we are looking right now is to scale this impact. So we're looking for program partners to move from 100 units of testing to thousands, if not more, in the coming year. And it easily will be replicated as we will step out and get a local manufacturer here. And instead of us running the program, design the program, we will have local organization to run it. We believe we have a universal product. Therefore, we worked hard in designing an easy installation guideline that anyone, he's a mason, is a master in his work or not, if he take this installation guideline, which is made of 9 different steps, we promise you to end up with a product that performs as we promise. So easy 9 step, you do the right installation with the right measurement, with the right alignment. And we try to keep it every time, we try to refine the material to make it much easier. So what did we achieve in the last year? We managed to install around 27 units in Bangladesh, or sell almost 27 units. We're serving 231 persons every day with these units. The installation was done across 5 different districts. We had a good support from WaterAid, IDE, and NGO Forum, much appreciated. And almost we're treating 28,000 liters of effluent every month. I would love to say it's a 28,000 meter cube or million, so this is the next step. And what we found out in our pilot, we were targeting low-income population, so less than $5 a day. And the goal was, we need to understand how much people are willing to pay, because subsidy need to be introduced somewhere, either to mason, either to sanitation entrepreneur who make the rings, and try to understand how to make it more, what kind of packages people would like it, what kind of installment can be done. So the work was made how to do this more local product. So to finish with, so we went last year installing 27 units in Bangladesh. We also have different pilots in different parts of the country, of the world. We have in Jordan, Lebanon, Gaza, Kenya, and we had other 5 countries now on the pipeline. We want to go from 100 units a year, and I want to be ambitious and say in the next 2 years, I want to put 100,000 units. Therefore, we need partners who can design program and take the lead. We are a company that knows how to build a product, but we don't know how to build programs. So I'm here today looking for partners. So if you want to talk, I'm here around the coming 2 days, so please reach out. Finally, I want to end with quoting one of the sanitation entrepreneurs we worked with. He passed away a few months ago, God bless his soul. His name is Alum Chacha. He's a sanitation entrepreneur in Cox's Bazar. We designed the business with him. And he never saw potential in making business from FSM. And he saw a big potential on it. So he said, people in my communities want a better sanitation system. They simply did not have the right solution until now. So thank you for listening, and any question?
Thank you very much, Bara. So I think presentation is over. So the participant, you can take part in the discussion. If you have any query, then you can meet up your queries. Okay.
That was sharp 10.
So okay, first you can ask the question.
Thank you for nice presentation. You have told 2-shaped separator was used to separate solid and liquid portion, right?
Mm-hmm.
I-shaped and L-shaped. Is there any difference in efficiency of separation? Like solid and liquid portion got 100% separated. If solid portion get some solid portion get into the liquid portion, will that be a problem in your system?
Thank you. This is a good question. So we designed a settling tank. First of all, Bangladesh was a very challenging country because the stool index here is always watery. So in good case scenario, we separate around 95% of the fecal matter from the liquid. So if we get any fecal matter, it will come to the settling tank and it will settle down. So this is why we introduced a settling tank. If we don't have a settling tank, the bioreactor with time or the biosand filter will get clogged. We have a unit maybe operating for more than 2 years. The pit did not really get filled, and the system did not get clogged up to this moment. So I think, or we did any dislodging. So the concept design is working great. I hope that answered your question.
Okay, thank you very much. So your question.
Thank you. Did you say the price was $60 of this whole system?
Yes. No. If we are doing retrofitting, meaning
Yes.
people have already an existing pit latrine,
Yes.
we install the ADU, this component, and this component, and this is around $60. If people don't have any toilet, they want us to build them a new toilet, it was $140. The price of the ADU, when we reach out to people, we put it for $10. I'm sorry, I'm not using taka. I mix.
Yeah, so in Taka, it's about 10,000, $60 is about 10,000 Taka, 14,000, for 140 would be around 16,000 Taka, which is equivalent to price to a twin pit latrine. So it's quite at an affordable range. Yeah. So what are really the challenges in getting it to the market? Is it the supply chain, or because the price is not an issue, because that is the price range that is that we have right now in the country?
This is a very good question. First of all, the awareness. People buy things that they see, they use every day. Our system is a back-end system under the ground. Selling a value that you don't see is challenging, one. Second is the educational and awareness. People want to buy a septic tank because they know it's good. So, because it's a public knowledge, it's good. If I come to him, my name is Bara, I'm from Jordan, I have this. Buy it, it's cheap, it's a fraction of the cost of a septic tank. He doesn't know. So we spent a lot of time, we developed a very nice communication material on WhatsApp. I can send it to you. But yet, what was very interesting, I can share, we installed a couple of units in Cox's Bazar. The first unit, we put it with a discount rate of 70%. Yet, no one was interested to buy. After the monsoon season, we had water above the pit for almost 30 days, 2 meters. What people noticed that there was no fecal matter around their home, and they were able to use the toilet immediately when the water went down. The neighbors in the block came and made a purchase order. So only when they see, they bought the value, they bought the concept. But I'm not a marketing expert. I think we need to design a program for 2 to 3, 4 years with an ambition plan to make it work. And happy to talk later.
Okay. Anybody? Yes?
So could you explain the EDU in a bit more detail? What's the mechanism for separating
Sure.
solids from liquids?
So the best picture we have here is this. We have a flow flush trap to capture urine and cleansing water, and we divert it back outside channel out. And the big flow comes from here to here. And anything solid, we have a special grid to catch it and take it down. So it's a system that requires no maintenance. Like none of the units we installed get clogged up to today. I don't know tomorrow, but in 2 years with 27 units, nothing get clogged. We design it in a way that it requires minimum maintenance. That was a key catch. Yeah. Thank you. This is a fantastic question for the fantastic slide. So the system volume, in Bangladesh, our intervention was focused on pit latrine. In Jordan, we plug it to a building. So the system net area is 2 meters square for 2 pit, but the volume of it can change based vertically. So if you want to make it bigger, to handle 3 meter cube, we'll have just more rings down. So in terms of net area is the same. In terms of volume, it will be just more rings. So we can provide a guideline on how to do sizing for the system. I hope I answered the question.
I think this is the nice discussion, but we have also many questions. Next time we can communicate and discuss with him. So actually, basically, I have many queries. So next time I will contact with him. So thank you very much. Thank you, everybody. Actually, I forgot to welcome you all in the beginning of this session, but now we can cover this welcome in the afternoon. So this is the first paper that is presented already. So next paper, I think that will be presented by Sonia Shahid. This is the, yes.
The sanitation data frameworks that we have in Bangladesh, there are some gaps. So one of the reasons why, even in one of the sessions today morning, when we were discussing, we actually found out that sanitation service monitoring is a very big... Yes. Oh, sorry. So service monitoring is a challenge. So what we did was also a lot of these frameworks that we have in Bangladesh right now are not informed by people who are using it, which is mostly the city officials or the data collectors in the field. So there is a gap. So we ventured into actually understanding where the gaps are. And the methodology that we used was to do consultations with sector actors, look at baseline data assessments that are already available. So we found that there were 6 cities which already had baseline data for sanitation. We did a mapping of all the service outcomes and system functions. And we looked at a global level Swiss indicator framework to see where the gaps are at the local level. So Bangladesh right now has 5 frameworks on which service monitoring is currently done. And following that, we made recommendations. So the 5 service frameworks are, one is the sanitation dashboard. So you can always go online and see the National Sanitation Dashboard. It's on sanboard.org.gov.bd. And then there was the other one that is used at the city level. So data collected at the city level is then fed into an IMIS system or a data system. And then there is one that is used by DPHE to monitor projects within their different projects. And then there was another one that was developed by ITN-BUET called the Mentor City Assessment, and a National Sanitation Data Command Center. So all these frameworks had they developed the framework based on different data points and different indicators. We compared each to the global Swiss indicators, because global Swiss indicators have been accepted by most of the international organizations and data development banks to be a standard one that can be followed. And when we did that, so we looked at the equity indicators, and we found that only 32% of the indicators were represented in across all the 5 frameworks. And also in terms of, in the context of Bangladesh, we expanded, we recommended a few indicators to be expanded because to the contextual needs of Bangladesh, which was absent. We recommended some indicators to be rephrased to the contextual need of Bangladesh, and we looked at few indicators that were not available. So some of the indicators that, that was not right now being collected was on indicators covering the needs of women and girls, so gender inclusivity, and another indicator with, on the needs of the poorest communities in a locality or community or city. So also on poverty. So if you look at service monitoring, it was not inclusive, and it was not, we were not able to understand really how much the poorest communities were being, where the service was being delivered to them. So we also recommended few indicators that should be taken up for advocacy. And then we looked at safety. Again, when we looked at across all the 5 frameworks, only 59 was being covered. From there, we had few indicators that needed to be expanded, especially on community toilets and public toilets, because that was not in the global indicator list, and we have our own definition of community and public toilets. Licensing requirements, health checkups that are regularly done at the city level for sweepers or waste workers. And we looked at rephrasing a few of the indicators and also looked at advocating. And then we looked at sustainability factors, where only 53% was being covered. And especially on sustainability, the financial sustainability was not being covered. So we did not know the investments that were being channeled into the cities, whether it was giving results that equated to inclusive and safe service delivery. Again, with responsibility, it was 57%, with accountability 67%, and with resource planning and management 17. Only 17% was being covered. So again, resource planning and management was a big factor here, where not really the how the resource were being invested was being reported, and the data was being covered within the frameworks. But the good news is, the cities that actually had baselines, they did have the data. The data was not just being translated into the frameworks and being reported neither at the national level or the local levels. Yeah. So that was the conclusion, and then we recommended a framework that we could actually take. It was a standard framework that we could take to all cities and nationally, and that can be followed. Thank you. I'll take questions.
Presentation on the policy for monitoring the evaluation. So it is important to make the policy that if we have to monitor any type of or intervention or something. So it's very important to make the policy. So this work is very good to find out the gaps in our policy, existing policy, and at the same time, she's already suggested some policy, some points to incorporate in our existing policy. So now the floor is open to all of you to share your knowledge, and also for if you have any asking, please feel free to ask him or anybody from the audience. Excellent. Actually, all desire already fulfilled. That's why there is no questions from the audience. So, yeah. Please. I have something. Still, you have 5 minutes to be here. So, actually, based on your this policy gap, based on your survey, right? So, whatever I found in your abstract. So based on your survey, so in case of the survey level, what was your actually the sampling size? How you decided the total number of sample? What was the respondent? So actually, I didn't read the whole paper, total paper. That's why I don't know. So thank you. If I could read the total methodology, it will be better. So we can hear from her. Actually, this is based on how they are managing this monitoring system. So far, I could understand. So, in case of is there any lagging from the actually the municipal authority or this local government authority? So, what I want to mean that. So, suppose sometimes we are putting some value. Just on desk, not going to the field or actual figure outing the situation. So is there any observation you have got?
So that was the biggest observation. The poorest people were not being consulted.
So did you validate your observation just based on their reporting system from the field level?
Yes.
Okay, thank you much. Mr. Aziz from ITN, you have anything? Since
One of the framework is
yeah, that's why I'm asking you.
then match the indicators with the other framework.
Okay, thank you very much. We can conclude here this session, this presentation. Okay, thank you very much. Next paper, I think that will be presented by Mr. Azizur Rahman from ITN. So this is also on the technology.
Thank you so much, sir. So this is Azizur Rahman from ITN-BUET. So my topic is the biofuel toilet. It's a promising alternative solution for on-site sanitation. So let's have a look at the background. So in Bangladesh, the sanitation coverage is almost 100%, but the pit latrines is the dominant one with more than 70%, and other one is the 30%. So the pit has some difficulties of fecal sludge management. After some times of using, it needs to dislodged and then managed by the whole thing. So there should be some solution that overcome this sort of problems. So in JMP 2022, they reported that the in-situ decomposition that contributed much in the country's safely managed sanitation. So the biofuel toilet is one of the on-site and decomposition-based toilet vermicompost production. So that is contributing here, and other with all other twin pit latrine and other composting system as well. So our study area was in the Amin Bazar, very close to Dhaka, and it was the 15 samples that the toilet has been implemented under the Gates Foundation Fund. And this is the biofuel toilet. It looks like it's a cross section. So there was a filter over there. There are some bearing material like coconut fiber, straw. Over there is some tiger worms, almost 300 grams is placed for each of the tank. And once the fecal matter drops, then it filters the liquid, and the solid retain over the straw and coconut fiber. And with time, the biofuel toilet operation, the tiger worm consumes the fecal matter, and it produces the vermicompost all around the direct drop. So this is the main principle. So these are some of the snapshots showing the different elements of biofuel toilet, starting from the casting of the porous slab, and then the final one is the complete picture of the whole toilet. These were steps. So our objective was to evaluate the biofuel toilet from the pit latrine alternatives. How does it perform? So we used 4 basic indicators. One is the hygienic condition of the toilet, performance of the filter media, as well as the volume reduction of fecal matter and production of vermicompost. These are the indicators that we followed for evaluation this one. And we conducted this study for 14 months for 15 biofuel toilets in the Amin Bazar. So these are the inspection methodology that we inspect the hygienic condition inside and outside the toilet, and also gather the user feedback. We observe the volume reduction of fecal matter and production of vermicompost physically. And then we took some photographs over time for each of the monitoring in each of the month. And after 14 months, we measured the total height and then some theoretical calculation, we compare with both, and then find the value addition of this biofuel toilet for fecal matter reduction. So let's look at the findings. First, this is the monitoring of toilet inside and outside. So green shows the good one, that means no odor, and the red or pink shows there is some odor. So in most of the cases, most of the biofuel toilets, except a few, we found that this toilet had no odor inside and outside the containment. So we followed the 3 conditions of a hygienic toilet that has been described by the government strategy. National Sanitation Strategy described 3 criteria for a toilet being as a hygienic toilet. One is the confinement of fecal matter, another is the scope of venting the foul gases, and then the sealing between the passage between the squat hole and the pit. So for biofuel toilet, we found that the ferrocym digester, so that confined the fecal matter during the service period, and we evaluated for 14 months. So that fulfilled the first criteria. And the biofuel toilet has a vent pipe, almost 100 millimeter dia, to escape the foul gas. That also meets the second criteria. And third one, it has a ceramic pan attached with a water seal. So that act as a, I think the water seal, and that gives the barrier between this sealing passage and the hole. So this looks like this one. So for all 15 cases, we found that this toilet fulfills all 3 criteria of hygienic toilet. So then third one, we check the ability of digester filter to drain the liquid. So there are some photographs not so good, but I think for our investigation, we had to remove the top slab and we have to observe all the things inside the digester. So with time, I think the digester shows the B4 is the ID number of this toilet, B4, and it shows not that much accumulation of liquid over the filter. But liquid accumulation happens after 3rd month for this toilet. So for B5, for 4th month, and the issue was that volume of the socket speed passing through this one. So there is a socket speed attached with the biofuel toilet. So that size was not that much big. So that couldn't drain all of the liquid effluent. So once the size of the socket speed is made bigger, then the issue was resolved. And that doesn't happen anymore from the 4th month and onward. So then we checked for the vermicompost production and volume reduction. So just around the direct drop, there are some black color that shows the formation of vermicompost and conversion of fecal matter into the vermicompost. So that direct shows in the figure. So definitely we also calculated some theoretical calculation if the toilet would work as a pit latrine without any filter, any biofuel, or tiger arm, other no things. So what would be the service period for this toilet? So we found that the volume that would be used or that we got as a pit latrine, and we also measured the total volume of that biofuel toilet for that particular year, and we find that the 6 to 10 times less volume accumulation for this biofuel toilet with the tiger Rahaman filter compared with any pit latrine if it did work at traditional pit latrine without any these sort of things. So we also collected the user feedback, and then toilet superstructure all are good, so people use that one and they are happy with that. And since this is not producing that much odor except a few units, so people accepted this one. And O&M was a little bit easier. Just they use the water to clean the pan and all around. No chemical use, nothing else. So that is. And the fecal matter did not drain out the surrounding environment. So from our evaluation, it appears that biofuel got the user acceptance for that particular study area. So in summary, the biofuel toilet can be available or can be made locally with the using local as we made for the other toilet components, including tiger worms, that is also available locally. And from the technology perspective, it can offer a odor-free and hygienic toilet and longer service period. That is the very important thing, that after 6 months or year, it requires dislodging and management of the whole thing. So that is the good thing that biofuel offers a longer period of service time, and it can solve many more problems like normal pit latrine. So the way forward that would be, since the emptying and other issue is there, so biofuel could be a solution for that particular aspect. Also, it requires a small amount of water for its operation, not that much. So our water stress area, that can be a good place for implementing biofuel toilet. And advocacy is important, because in institutional regulatory framework for fecal sludge management that has been approved by the government in 2017 in the rural part, so they described or they suggested the technology would be like this one that doesn't need any pit emptying or frequent emptying. So biofuel could be one option, and then advocacy at national level should be a good activity for the biofuel promoter. And necessary capacity being important, because there is a filter, there are some construction specification, so any ordinary machine cannot do that. So they should have some sort of training. So that's capacity building is important, as well as the development of entrepreneur to expand the whole country. Because if there is a single agency supplying biofuel toilet, so I think probably they will not be able to capture the whole demand of the country. So that's the thing. So that's all from my side. Thank you so much. If you have any questions,
thank you very much, Mr. Azizur Rahman from ITN. So yes, Shumaya, please. Next, please wait for next asking question.
Thank you for nice presentation. I have some question regarding the color code you have used regarding odor.
this
Could you
one?
please explain? I
This one?
didn't understood. Yes.
This one?
Yes, yes.
So the story behind this RUET was that this has been installed in a house who dedicated this toilet for their tenant, not for them. So after 3-4 months, the tenant left over the house and they stopped the using. So once new person came, and then they started with that, and some sort of regeneration took place, and then started. So that's the reason behind this line.
Okay, I will ask to ask the question. So second person, yeah.
This is Ashraful. I am working at ID Bangladesh, International Development Enterprise. I am working here in Dhaka. My question is that, yes, definitely this is a very nice technology in terms of safely managed sanitation as like that. But question is that when community using this system, we know about the rural people culture, because when during the using of these sanitation facilities, yes, definitely. When community using these facilities, there may be some fecal is in the cover or pan inside of the pan. So how actually, if there is no chemical allowed inside of this latrine, how they maintain the hygienic condition of these facilities? This is the questions.
Okay, thank you so much. So I think if you have attended in the earlier session, then I think you can recall the speech of the biofuel toilet proprietor Sarwar Bhai, that there is a essential importance of user acceptance, whether they will accept this worm-based toilet or not. This is the first question. When they installed the 15 units, they surveyed for many of the houses, but some of the houses did denied, no, I don't want to install a worm-based toilet inside. I will sit and there was a worm under my foot, so they did not allow. So using the chemical prohibition and less water, and not drop the cigarette butt and other things inside the pan. So these are the requirements for operating this biofuel toilet, if we really want this to be acted as biofuel toilet. So that sort of motivation, that sort of control, that sort of context we need to understand. Otherwise, if we put all the solutions everywhere, it will give us a bad impression that technology doesn't work. But okay, sir. Thank you so much for a nice question. So vermicompost, from our side, we evaluated this toilet. Technology provider or from project, they installed those one. User accepted those one. So vermicompost they used or not, that I didn't take any record. But interesting thing is that I think in 2023, so we again visited those houses where we installed this sort of toilet a long back. And many of the toilets we found that are working and worms are alive. So that's the good thing.
Okay, thank you, Mr. Aziz. So please, your question.
Yes. Thank you, sir. This is for extreme water stress areas, right? In rural areas.
This has water requirements not to use more than 2 bodna, I think 3 to 4 liter per toilet use.
Okay.
So this is the requirement. If you use more water, like opening the tap and running water and wasting out, and so that doesn't allow for this technology, because each of the technology has some requirements. We have to understand this one. Otherwise, we don't get the.
So
water
my question is, how will it function in a flood-prone area where there is constant flood?
Yes, probably we won't suggest if the user, particularly for that particular area, they didn't control the use of water. So probably the biofuel toilet won't be the appropriate one for that. Maybe the other one.
Can I add? Am I allowed as a technology provider? Thank you very much. Thank you very much indeed. In fact, what I understood over the period of time, through the experience of 8 or 10 years, in flood-prone area, flood is a challenge for any technology. What happened to the pit latrine? They raised the land. So we'll do the same thing. Biofuel toilet will be installed in a raised plant. What is the comparative advantage? Aziz Bhai already mentioned. It takes 6 to 10 times less time to fill it up. So just imagine there is a flood and biofuel toilet and pit latrine. There will be less pollution through biofuel latrine. That's the comparative advantage. And then nothing is perfect in this world. So we have to look for the comparative advantage. That's what I wanted to say. Thank you very much.
Thank you very much. Actually, I will talk about this technology with Mr. Aziz. So next time. So now I would like to invite to present the next paper. Yeah, I already thanks you. So I'm like to invite to present next paper. This is Tawhidur Rahman. So service level benchmark for the evaluation of the IWM, please.
So good afternoon, everyone. So have you heard about this phrase, like the service level benchmark? This phrase, just raise your hand. Like, have you heard about, so that I know the knowledge, like the benchmarking system of you for the integrated waste management plan. There are so many benchmarking systems in water supply system and sewerage system, but especially the integrated waste management plan, or especially for the fecal sludge waste management plan. This is the first one developed by the CYS FSM support cell, Department of Public Health Engineering. So what actually this framework has, so it started with the examination of the raw sludge, so raw sludge at the treatment plant, then the black water after the solid liquid separation from the planted or unplanted drying bed, then examine the quality of the treated water at the polishing pond, and compost quality, or either if you have any sort of gasification or the plasma gasifier, then you need to check the air quality. So it has like 5 indicators to measure the efficiency of the fecal sludge integrated waste management plant, including a fecal sludge management system, like this 5 indicators, like the adequacy of the capacity of the treatment of the fecal sludge, then the adequacy of capacity for the treating the solid waste part, efficiency of the drying bed to separate the solid part from the fecal sludge, and the efficiency of the liquid treatment, and the co-composting, quality of co-composting. So this is actually the integrated waste management plan. So what it mean by the integrated waste management plan, in a single treatment facilities, we treat both the solid waste and the fecal sludge. So how? I'm not going to more details on the treatment technologies or the separate part. So you all know the treatment of the fecal sludge part, like with the planted and unplanted drying bed, we separated the dry part, and the liquid part is treated by the ABR, and it goes to the polishing pond and treated the liquid part. And the solid part is go to the co-composting from the waste separation. In the solid waste part, it's separated to combustible and non-combustible. Combustible waste goes to the plasma gasifier to treat the combustible part of the waste, and the non-combustible, more or less the organic part, is mixed with the dry sludge to make co-compost. So we need to test the quality of the wastewater, quality of the co-compost, quality of the air quality of the plasma gasification unit or the gassing unit from this part, from the starting to the end portion. So this is our existing national standard. Like we have National Sewerage Discharge Standard, ECR 2023. So it has like 8 parameters. So we need to test those parameters from the 1, 2, 3 these areas to check the treatment capacities of the system, like how the wastewater is being treated in different part of the treatment system in the fecal sludge treatment plant. Or I mentioned that there's a integrated waste management plant. So for the co-compost, we have already a national standards. We need to measure the physical properties and also the chemical properties. So we need to check this. And for those plants, so already we have like 11 integrated waste management plan implemented in different municipalities. They have the plasma gasification unit. So those treat the solid waste part in that gasification unit. For those gasification unit, it need to comply this standard. So this is the actual service level benchmarking system, like what I shared with you. Like it has 5 indicators. The first one is the adequacy or the capacity of treating the fecal sludge. So what you need actually, you need the treatment plant capacity, then dividing this by the total fecal sludge generation of your city or the area. When you divided this portion, you get a value. So this will the final outcome of that indicator. At the same time, the solid waste, you need to quantify the plant capacity. The plant capacity of the landfill capacity, which already present in the municipality, and you need to divide this factor with the total generation of the solid waste. So by dividing this, you will get the total efficiency of this indicator. And the third one is the same, like the separating the solid part from the fecal sludge. So in that case, you need the total fecal sludge delivered to the treatment system. So how many vacuum trucks are coming to the treatment plant and dumping the sludges, and you need dividing this value with the design capacity of the treatment system. So from this, you will get this indicator, like the efficiency of the drying bed, so separating the solid part. And finally, the efficiency of the liquid treatment part. So for the liquid treatment part, what we did actually, we treat the wastewater from the polishing pond on the final outlet. So I showed you the parameters provided by the Bangladesh government. So in that case, you need the number, you need this one, the number of parameters past the standard and number of parameter actually you tested. So you need to divide at these factors. So these are the gist. So I'm telling you the gist to get how you get the scoring or how you get the numbers to monitor the efficiency of the fecal sludge or integrated waste management plant. And finally, the quality of co-compost. So same things for the co-compost, the number of parameters past the quality standard divided by the total number of parameters tested yearly. So this document also has a measuring frequency or capacity, like municipality or the plant operators need to measure this quarterly, and they need to transfer this data to the municipality or the city corporation in a 6 monthly basis. And municipality and city corporation, they will share this data yearly basis to the local government, and they will incorporate this data in the national sanitation dashboard. So this is a sample report performance systems. So at the top of the performance system, the name of the municipality and who is reporting where, the reporting year, the reporting frequency, and all these parameters. So all these indicators. So these are the and the performance targeted. So for the baseline period, you need to set a performance standard. Like I have a plan to achieve this amount for next year, like 90%. So after finishing 1 year, you need to assess the full system, and you need to compare your performance index to your set of performance targeted performance. And then ahead, you can take few action plan to increase the capacity of the full treatment system. So we have a QR code of this full service level benchmarking systems already published at Department of Public Health Engineering's website. And you can get this document by scanning the QR code. It has more details, and we provided the testing procedures and everything in this guideline. So I think it will be more helpful for the plant operators, for the city authorities, and for the local governments to monitor the full treatment systems. So everyone, what actually need to run this plant more efficiently, the willingness actually. So the city authority or the service provider need their motivation from themselves, and they need to create the bylaws inside their bylaws, they need to incorporate this service level benchmarking system to actually implement this guideline at the field level. So this is from my side. Thank you. Thanks. If you have any questions, so.
Sorry, I'm questioning too much actually today. It's great to know that DPHE has a benchmark, but if I talk on ground, that WASA is busy in preparing sewage line and treatment plant. DPHE is doing in little bit of municipality level or some of the city corporation that about the construction and other toilet facilities. My point is, we as a nation, we don't have any single authority to look for these things. But we have prepared the benchmark plan or benchmark level or benchmark report card system before. My point is, we got to first think and plan and execute that where our nation is going and how we got to manage this figures class management in the next 30 or 40 years. Because we are saying within the next 25 years, the half of the population will be staying in the urban areas, I mean in the cities. So we got to make that thing first, then implement it. During implementation, make this benchmark, and then produce the report card. Thank you.
Thank you. I think it's a suggestion.
Yeah, thank you very much. Actually, there should be a guideline that to be followed by all the agency that implementing agency. So actually benchmark, who is preparing this benchmark, that is the matter also. So benchmark should be prepared centrally, and that should be obeyed by all the agency, implementing agency. So it could be facilitating by the DPHE, no problem, but WASA or some other agency, they should take part in this preparation of the benchmark, no problem. So thank you very much. Next, yeah. So yes, okay.
Can I just supplement? I mean, Department of Environment has got certain standard, and that's binding to everyone, including WASA, DPHE, and everyone. So sometimes, I mean, they do update, like they have got standard for industrial effluent, for the fecal sludge materials, a number of other things. I can't remember exactly about the water one, but especially on these ones that Tawhid was showing, they have got this standard, and that's binding. And the other thing which I want to raise is interesting. In case of Bangladesh, whoever formulates the law, the last one would say the last line, অন্যান্য আইনে যাহাই থাকুক না কেন ইহাই বলবৎ হইবে বা ইহার সকল আইনের ঊর্ধ্বে এটা থাকবে আর কি তো ওইটা দিয়ে আবার sorry I mean if there is any foreigner here meaning that the law which will be passed the latest one will always say that this will be the supreme and binding and the all other ones I mean may not need to be taken into cognizance or this one will get supremacy over the others. I think that's the right correction. This one will get supremacy over the others. Yeah.
Thank you, for his valuable comments.
Yes.
Hi, this is Riaz from UNICEF. Just for the report card, there are 5 indicators. Can you mention about the correlations between these 5 indicators? So if we want to check that if the number 1 indicator is not meeting the target, is it possible that it is meeting the number 5 or 4 indicators? Because if the treatment plan doesn't have the adequate adequacy in terms of capacity, whether which means the design criteria we have set is not working well. And even after that, if it is not working well, then how this quality of co-composting and efficiency of liquid treatment will meet the standard? That could be a question, because if this is a real-time example I'm seeing here in the report card for, I believe,
it's the Shahid
municipality.
One, yes.
I can see that in the first 3 indicators are not meeting the standard, but the last 2 has met the standard. How this is possible?
This,
technically, that's what I want to understand actually.
Okay, thank you for the wonderful observation and your questions. Like these are not the performance targeted. This targeted by the authority or the service delivery people. So these are not the standard parameters. Like I have set 90%, so it achieved the 90%, so it's okay. This not a judgmental thing. So this set it by the plant operator or the municipalities level. So I'm clearing is this is not a setup standard like 90% is the benchmarking level. No. So actually after 1 year you will get the value like performance indicator if you have a smaller capacities of the planted or unplanted drying bed, then immediately you can take necessary action to add more planted bed. So it's a decision-making, also a decision-making tool for the city authority if you get a low score. Finally, it will affect the treatment stream, like if you don't have the adequate capacity to treat the solid waste, you will not get that amount of mark at this scorecard. So it will obviously gives a certain indicator for the decision maker to do something or increase the number of treatment system for the municipality or for the cities.
Okay, yeah.
Thank you, nice presentation. My question is on the standards that you are referring. So I'm a practitioner also for sanitation for fecal sludge in Cox's Bazar in the refugee context. So what we have seen when you talk about co-compost, that means mixing the solid parts from the fecals with the kitchen waste, the organic parts. There are certain risks from the solid components of the fecal matters to have helminth eggs and to have pathogens. So as we are referring the standards of composts, we have not seen any indicators that suggests a guideline value for helminths and for the pathogens. So whether in DPHE FSM Swiss cells supports identified any opportunity to improve on that parts for these parameters, and also on the other end for the sewage discharge, we saw that the footnote, it says that the discharge always has to be released to surface waters. But in case of soil infiltrations, whether the same DPHE FSM Swiss support cell have identified an improvement that can be done on the parameters in case of infiltrations. to the underground? Thank you.
Thank you. Thank you for your questions. Like for the pathogen removal, we also we incorporated that. I think you saw this graph developed by the WHO, actually the pathogen removal. So we included this part also during for the co-composting. They need to follow these criteria to deactivate the pathogen. So if you scan the full book, I have more details on that benchmarking systems. So for the second questions, can you repeat again? Like most of the time we.
Sorry. The standard says the parameters are when we are releasing it to the surface water, means drainage, open drainages. But if we are releasing it on underground, infiltrating underground, there can be a revised standards. Whether there is an opportunity that you have seen for that different indicators.
I think you know the DOE, they have guidelines. You can't infiltrate anything underground, like any kind of sort of wastewater and something. So DOE also have that, they have mentioned these things. You can't infiltrate that wastewater, treated wastewater part in the underground.
On there, the confusion remains because the majority of the latrines in Bangladesh is pit latrines. The primary treatment happens, and that treatment, the infiltration goes underground.
No, they have a treatment systems like, the soak pit. So they treated that different part. It has layers, different layering systems. So it actually treated the wastewater and it infiltrates surrounding in the water bodies. But you can't direct inject or infiltrate that wastewater into ground, I think.
Okay, noted. Thank you.
Thank you very much. Actually, in my case, you want to say?
Sorry, I'm a public health professional, not an engineer by profession. So I'd like to add just 2 things. One, in ICDDRB, Professor Sirajul Islam, he did a study and I was associated, which is the mobility of the bacteria from the latrine. So the horizontal movement and vertical movement, it's interesting to see that horizontal movement is much better than the vertical movement. That's why what people are saying is that, let's say the WHO recommendation is 30 feet. Now it's very difficult to say it in a poor household condition. It will be a bit of cruel and mockery to them who have a homestead of 10, 15 feet. You can't go and say that make your latrine and tubewell 30 feet apart. Yeah. So the realistic suggestion is to have the tubewell bored in such a way so that there is quite a bit of difference of 20, 30 feet, so that the next layer, so that the bacteria cannot go deep and really penetrate and infiltrate that layer. So that's the kind of suggestion that instead of saying, because usually the latrine that we do in the village or rural setup, 5 rings, 3 rings, those kind of things, not more than that. That's the common practice. So you need to deepen the tubewell part. That's one thing we need to remember, that the horizontal movement is very much possible, but vertical movement is difficult. DOE's inhibition on infiltrating anything underground which is not safe for the shallow or deep aquifer. If you go to Sabah, Ashulia and all these areas, all the factories now, instead of letting it into the river, now they are sending underground. That's a very common practice that through our working experience we have found. And the last point, what you raised about helminth, that is the main challenge of fecal sludge management treatment plan. The technology that we have designed, apparently they cannot kill those helminths. So a temperature difference of 3 to 5 degrees centigrade can make a huge difference. Usually it can go up to 50, 52, but in order to, then helminth will remain in dormant form. Whenever the moisture will come, it will survive again. So through the compost process, if you can raise the temperature another 3 to 5 degree, then it can be deactivated. And in number of the fecal sludge treatment plant, if you might have noticed that through the solar, I mean, they try to increase that temperature in different ways, and that's how they try to deactivate. That's the main challenge that we are actually facing.
Okay, thank you very much. Actually, that I wanted to say about that about the microbes actually, fecal matter, fecal coliform or something. So one thing I'm wondering about that the presence of fecal coliform in a groundwater. Many people are penetrating our fecal matter in the underground through the sock pit in appropriate condition. But whenever we are checking the groundwater for the fecal coliform or E. coliform, I didn't find any coliform from the groundwater. So it might be like that, in favorable environment, they will kill. So I'm not sure about that. Is there any matter of worrying that if fecal coliform penetrating in the ground, under the ground, it will affect the groundwater? I think might be some period of time it could be, but after some period of time, longer period of time, I think it will be killed.
I think we can do extra research on this topic.
It's okay. Actually, we are talking out of our time. So since we have much time, that's why we are talking about that. So now I would like to thank him. So Mr. Tawhidur, right?
Thank you, everyone.
Yes, okay. So this is the very good and interactive session for the presenting technical papers, mostly on the technology, sanitation technology. So basically, technology, efficiency of the technology, the performance of the technology, management system, these subjects actually covered in this presentation. So many things actually we have in our mind, so we can discuss many times. But whenever we are talking about the efficiency of any technology, efficiency, I think we should measure based on what was our actually target, design condition, and achievement. So if we consider beyond the design coverage, that means how many coverage we want to give for this technology or for this unit. So and if you measure, so it is the capacity and how much is performing. It is not the real efficiency. So suppose it's like that, 100 ton or 100 meter cube we want to treat, and accordingly we design the unit, and we are putting 100 meter cube matter, and what is the performance. This is, I think that will be the measurement of efficiency. So what I found from the presentation of Tawhidur Rahman, so is capacity and how much is treating, right? It's like that. So do you have any information about that? What was the capacity, and that capacity is, that means why not they are not meeting the capacity? That means suppose 100 household they want to serve. So 100 household are not serving? Okay. So another asking from Mr. Azizur Rahman. So in case of your biofuel toilet, no. Yes, your presented toilets. Yeah, I know. It is not your toilet. You are using the most sophisticated toilet. so it's okay. So in case of your vermicomposting, since it's the continuous feeding system, right? Continuous feeding system. So continuous feeding system, there might be some percentage of the raw fecal matter, and certain portion is gradually getting the compost. So whenever you want to collect the compost from the same unit, so is there any chance to having the raw fecal matter in this compost?
Yes, sir. Since it's the fecal sludge, so definitely there are some chances of getting contacted with this stuff. So I can share my experience that when I did this study and I visited for the sampling, so my office colleague, they don't allow me to enter into the office directly. They send me to go to the toilet, wash your hand, and ensure that you are not carrying out any fecal matter within the campus or office. So this sort of challenge that I faced for the 14 months when I did this study. So that's the practical thing. So definitely there are some chances when you collect the vermicompost all around the direct drop in the, I think, yellow color shape. So there is a chance of putting some raw sludge as well. But you need to be safe so that you leave some vermicompost so that you don't get touched with the raw sludge.
Okay, thank you very much. Actually, I had an experience about that whenever I'm conducting my research from the septic tank fecal sludge and treating, and I wanted to conduct my experiment in our laboratory. My laboratory technology didn't allow me to test the sample. So this is a bad experience for me. Thank you.
Yeah, thank you very much for allowing me to share the practical experience. Aziz Bhai was involved during the study time and afterward time to time, but I'm involved throughout the period. So what is the advantage in biofuel toilet? There is no bad smell. So you can open the total cover of the pit. And from the side where the vermicompost accumulated, you can take it out carefully. And in the middle, the fresh fecal sludge are remaining. So that is one thing, and no bad smell allowed the people to...
Chance of raw fecal solid.
Because of the construction model.
It is continuously feeding by the people.
Yeah.
They're defecating, coming to the system.
Yeah.
So whenever we are taking the compost, we want to use in our cultivar land. So there might be chance to come up.
Yeah, in that case, what Aziz said, that is true, but the advantage is there that you can open the total cover and you can,
Okay, thank you very much. I think we can wrap up this finishing. So everything we have already discussed, many matters. So it is a good opportunity to learn the many technologies and all systems, and also the management system, management practice, our monitoring systems. So it's okay. So I would like to thank everybody. It's a very sleeping time so far, because this is the time for after the lunch. So this sleeping time, actually you overcome by your interactive discussion. Thank you, everybody. So we can take a group snap, please.
A small announcement from the organizing committee. So in our closing session, actually we will declare the best oral presentation award, who will win that, and he or she will get a prize from the organizing committee. So all of you are invited in the closing ceremony to know about